Ready? Ready? It is changed. May I now please call upon Mr. Anand Ramamurthy, Micron Technology, as a moderator. We welcome you, sir. And along with him to share the dais, please welcome Shri Naveen Bishnoi from Marvell, Shri Hitesh Garg, NXP Semiconductors, Madam Malini Narayanamurthy, Renesas, Shri Balaji Sobrirajan, Semiconductor India and R&D Center, Shri Neil Gala, Encore Semiconductors. Please welcome all of them with a big round of applause. Thank you. Welcome, sir. I shall now take a moment to introduce Shri Anand Ramamurthy. Mr. Ramamurthy, an alumnus of IIT Roorkee, has over 2 decades of global experience building high-performance teams, introducing flagship products, scripting executable strategies, driving non-linear business growth, and leading organizational transformation. Sir, we request you to kindly steer the panel discussion.
Good afternoon, everyone. We got third time lucky. So I know this panel is between you and lunch. So the first promise we make is we'll try to make it so efficient that you get to your lunchtime on time. So we have a wonderful panel today with a great mix of multinational and local startups. Maybe I'll take a few minutes to kind of set the context and then have our panelists chime in with their thoughts and insights. I usually don't have this deep baritone. I have a bad cold, so I'm sounding much better than I usually sound. In terms of the context of the topic today, we're trying to understand between all the multinational design centers and the startups that we have in the country, what kind of designs are we working on, advanced designs, emerging designs, what kinds of tools, talent, infrastructure it needs, and eventually many of them will go on to high volume manufacturing and help with fab loading. That's kind of the big picture question we're going to address today. Now, before we get to the panel, I just wanted to share some of my thoughts and comments. I'll try to overlay the Micron world wherever possible. Micron has already gotten a lot of plugs, so I won't overplug. But in terms of understanding the state of the union of design centers in the country, I speak for both MNCs and local startups. And I think what applies to us will apply to many of my peers, right? If you look at the design templates that we have, the design template number 1 is essentially a strategic bet template. Very often, you just take a bet based on the talent base, based on the needs of the company, and you have the operations go and design something. To give you an example, a couple of years back, we took a bet on DRAM design in India. Now, please understand there are only 3 large DRAM vendors in the entire world, and the DRAM talent pool, end-to-end design talent pool in the country is next to 0. So we go ahead and hire a brilliant set of new college grads. We have a couple of good talented lateral hires that we had from different parts of the world. Put a team together, had them train, had them travel to different sites within Micron. But this is an example of trying to usher in advanced low-power DRAM design in the country by largely making a bet. And bets are bets. It can go wrong. In our case, thankfully, it went well. And you'll be happy to know that we had first silicon pass, no reticle revision in our business, as we call it. And that's a great example of what I call a design template led by bets. The second template, which is the more mainstream usual design template, is we start with essentially an augmentation model. And there's nothing right, wrong, or bad about it. It's more about a combination of cost arbitrage and the scale of talent that we have in the country. So you start with the layout, verification, validation, some very important part of the design flow. And over a period of time, you find that many of these teams often scale beautifully and end up into owning more and more design programs, which gives you the confidence to entrust them with a big design. That's the design template number 2. The template number 3, which is most exciting in my mind, and I'm sure India, with all the great policies that the minister talked about this morning, the DLI schemes, the incentives being given, the access to software and tools, is essentially a pathfinding design infrastructure. Like for example, again at Micron, we have a team that is looking at the kind of transistors and capacitor structures in 3D that we will need for designs probably 5, 7, 9 years down the line. They're trying to model, without actually having access to silicon, what kind of designs will actually be viable and make things happen. That's a pathfinding bet. I'm hoping more and more of companies will do the pathfinding bet because India is having more improved infrastructure in terms of design and broader ecosystem. And the last template, which I think is more country specific, like you have a need in the country and we'll have panelists talk about it. It could be an application which is very India unique. It could be a two-wheeler EV market. It could be a power meter. If you have an end market which has specific needs in terms of design and features, the cost arbitrage model is already working. I'm reminded of over a decade back when I was a country head for an automotive tier 1. Tata Motors approached us and said, listen, I want an infotainment platform which is cost effective, has unique features needed for India market. Can the team go and build it for us? Which of course the team did. But the beauty of that was we had a market need, we had the design center actually build the platform, and lo and behold, even we had it manufactured in Pune, Chakan, kind of completing the holy grail of starting from design, meeting a customer need, and taking it to high volume manufacturing in the country. So these are many design templates. As we go around the panel, we'll try to find out what's working for many of our peers. So with that context, Naveen, I'll start with you first. The first question I have is, at Marvell, when you look at your portfolio, end market verticals, give us a sense of what kind of designs your teams are working on, which of them you believe can become scalable and reach volumes that can possibly start doing a lot of fab loading. And also please introduce yourself.
Thank you, Anand. Good afternoon, everyone. I represent Marvell Semiconductors, which is a fabless design company. We're primarily playing in the data infrastructure domain, and then what we say is that when you talk about data, we do the processing of the data, the movement of the data, the storage, and in keeping it secure. So that's where the Marvell play is, and in the India Design Center is a replication of what we have seen for many other design centers, is a footprint of the global headquarters with a huge engineering community, and then playing the design and then other roles in all the product lines that we talk about in the infrastructure domain, right? If I pick up few of the domains, or at least the biggest data infrastructure fab or fabless product that we have been doing is in the domain of AI and data center. What we started with, the traditional CPUs and then the GPUs came in, we saw a need of a lot of accelerated computing. And that's where we have a product called DPU, which has been there, started with the data center, now is proliferating into 5G and enterprise as well. And that's been one of the building block for accelerating computing. But what we are seeing in the last few years, and especially the hype / the news around the AI, we are seeing growing needs of this computing to a general purpose GPU that can fit in, and then going from that general purpose to also some of the custom computing for the specific AI workload. Now, if you look at the traditional data center, we have been talking about a 50 gig, 100 gig, 200 gig speed. And then what we have is from the systems to the switch and then connecting within the data center to data center towards the cluster. We have been able to do that. But as we move to the AI applications, this speed is going from that 100 and 200 into 800 gig. And then that's enabled now with what we call as the optical connectivity. And so it's no more that you have the traditional connectivity, but it's the optical connectivity which is coming all the way down to the systems level itself, right? And now this is going to push us towards the 1.6 T and 3.2 terabyte, that's where the next innovation is coming in. So that connectivity is what we have been doing a lot of. That's our leadership we have been doing. And then add to that the custom silicon for the AI workloads that I'm talking about, where you move from a general purpose BPU into a more cloud or a custom clouds or a custom silicon for that, which is where we go and then build lot of processors or for these special AI and data markets.
Thank you, Naveen. And if I have to ask you, if you remember the 4 templates I talked about, would it be something like, was it a bet in the India Design Center, or did it organically grow over time? Just any commentary there? Like.
Yeah. For us, it's been a very organic, a mix of organic and I would say is that. So a lot of you will know Marvell is a company of 9 acquisitions over the last 5 years, including 3 acquisitions from the India ecosystem as well. So we have supported the India innovation and then the upcoming IP from there. So a lot of growth has been a continuous development. What you start with an extension so start with the value or the cost, right, Arturaj, and then move towards that what we call as a value, where you show the numerator that it's not the denominator cost that's playing it, but the numerator value you add is why you come and do the design center. And now we are in the transformation from converting this value into what you call as a business, because you can do a lot of these designs for the India and other regional markets as well.
Thank you. So Hitesh, I'll move on to you now. Loved Lars' energetic presentation on the automotive State of the Union. But similar question, Hitesh. You have significant design and sales footprint in the country. So please share with us what kind of emerging designs you see that are going to scale, and how does NXP play in all of that?
Thank you very much. Now, you saw the presentation from Lars. Of course, that was the automotive world view, that how we see the automotive world growing. I think this is one industry where, of course, NXP is working on multiple domains, but automotive is one of our biggest growth area, what we see. So software-driven vehicle, so is definitely one of the key factor for us to growth. We are talking about ADAS, autonomous driving. That's another factor that we see is a growing demand. The third is connectivity inside the car, so high-speed interconnects, so that is growing. Then the fourth trend that we see is electric vehicles. So we are seeing more and more growth of electric vehicles. So battery management and those kind of topics are also very key for the cars. So we, from NXP side, we have a complete portfolio in automotive, and that's what we are currently focused at. Apart from that, I would say traditionally we have been a security company. So we call it a secured connected edge. So as Lars mentioned, the next decade, it belongs to secure connected edge. So whether we are talking about cars, whether we are talking about IoT technologies, security is the key need for our markets, or when we project the future. So I think these are the key topics that we are focusing on. At the same time, we are also touching upon, we see a strong growth coming in the industrial area. At the same time, communication infrastructure is also growing at a rapid pace. So looking at these market, we see the semiconductor, as we all project, is going to be a $1 trillion market in 2030. So we see only automotive is going to be around 462. So 40 is quite a lot of significant market share of automotive in the overall world of semiconductor. At the same time, Lars also touched upon about our India center. So he said a lot of designs, advanced designs are done in India. So we have around 35% of R&D of overall NXP R&D is sitting in India. So we are doing the latest and greatest chips. Lars also mentioned about 5 nanometer designs. So those kind of advanced digital design, analog, RF. More than that, system designs are also done out of NXP India. So we are, as maybe my colleagues, so we are a horizontal supporter to our, I would say, overall NXP. So playing in all the domains, including system and software.
Wonderful. Thank you, Hitesh. One follow-up question for you. Would you say that, I think Professor Rao was commenting that R&D should be global, right? And we're all most of us are global companies. We'll have Neil talk about his journey in a bit. Given that, do you see that customer feedback on features, does it really help us to go tweak a platform or an approach, or your PRDs and MRDs? Just give us some commentary on how does the local market feedback, if at all, plays in your overall design objectives?
No, absolutely. I think we are already there. I don't see there is still a talk about that we are not global. I think for last 5 to 10 years, we have all been playing at a global level. And of course, whenever we are doing the design, so it's for the whole world market. You asked about the customer feedbacks. Of course, we have the key customers. The lead customers are now sitting in India, and we are interacting them on a daily basis. They are giving us feedbacks. Not only feedback, we are kind of defining our roadmap also with those customers. So it's getting more and more globals, but defined in India, but going for the global scale.
Wonderful. Thank you. I'll move to you now, Malini, and the question is similar, but maybe on top of the question around the kind of advanced designs that Renesas is working on, also give us some commentary on talent, skilling, infrastructure that you are keeping in mind while building these teams.
Okay. Hi, everyone, and I represent Renesas. So the purpose of Renesas is to make lives easier. Now, if I go to a teenage kid and I say, how can I make your life easier? They're going to say ChatGPT. Now, that's one way of thinking about it. But at Renesas, we work on things that make our everyday life easier, all the way up to things like automotive driving as well. So if you look at the different verticals that we have automotive, we have infrastructure, industrial, and IoT. And in each of those, we develop chips to sense, to compute, to move data around, and to actuate. So just a simple example, just to get lots of students out there as well. So, for example, if you were looking at automatic braking, you have to sense, and when you sense, you need your radar and your camera to give you data, and you sense that data. You have to compute that to figure out whether you're making, the decisions that you're making are right or wrong. You have to actuate, you have to brake if there's a car nearby or an object nearby. And then you have to be able to move all this data around. So we build chips to do all these different kind of things. Now, just to give you a quick example, since there are many different segments that we work on. For example, sensing could be CO2 sensing, or water meters, or energy meters. On the movement of data, there's 5G, there's Bluetooth, Wi-Fi chips that we make to enable these kind of things. On the computation, of course, there's microcontrollers, microprocessors, and actuating IGBT, MOSFETs, and motor control, etc. So Renesas works on a whole gamut of embedded applications. In India itself, to answer your question, Anand, in India itself, it's a mix of what you said. There's a bit of product development, and there's also augmentation. And we have a collaboration with the TCS Innovation Center as well to try and build future designs. And over and above that, one really different thing about, I think, Renesas is that we build a lot of systems in India. So if you walk into the office, you'll see things like a fan hanging, or you'll see someone testing a fridge. So, yeah, that's
Wonderful.
a little bit.
Thank you, Balani. I'll move to Balaji now. Balaji, Samsung has a very large canvas playing field, and the research establishment is very well known. So maybe in addition to end products, if you could also throw some light on foundational technology that you guys are working on, and how does it look like for you?
Thank you.
Not the most intuitive microphone that I've seen.
Can you hear me?
I wish I could help. I struggled myself.
Sure. Thank you. So thank you, Anand. And I'll try to link what we are doing in Samsung in India, research center, and also to the templates, what you're talking about, to give by starting with some of the growth segments and what are the core technologies that are driving the growth segments and what we do at India there. So if many of us spoke about, even the previous presentation spoke about automotive, EV, I think Malini spoke about, again, automotive and industrial applications. Naveen spoke about AI, right? These are the core technologies, right? So automotive, industrial, IoT, HPC, these are touted to be the most fastest growing technology segments in the next few years to come. If you have to look at some of these technologies, I would say some of the core foundations that are driving this, first one is connectivity. If I have to look at connectivity, we all speak about, when we talk about 5G modems, right? We talk about, we want low latency, we want high bandwidth, we want high density, but a variation of that, when you look at it from an industrial point of view, we can work with low bandwidth, I can work with high density, and I can work with high latency, right? So this is what we call as red cap, or the new technologies that are coming in, which will be critical from an industrial IoT point of view, right? So the reason I'm talking about both these things is if I look at automotive, if I talk about industrial, some of these technologies from a connectivity point of view are critical, and at our research center in India, we do a lot of work on these fronts. So this is one. Second driving factor I would talk about is sensors, right? And sensors, we spoke about importance of sensors in the automotive side, but even in the industrial, sensors are going to be very important. And sensors are not just about radar, LiDAR alone, but if you look at automotive image sensors, if you look at industrial image sensors becomes very important. We are very proud of the fact that we are leading design house, including in India, research center, on the image sensor front. But image sensor on a mobile and image sensor on automotive, the needs are extremely different, right? On a mobile, you want best color, best clarity, and best photograph to be taken. But as far as automobile is concerned, I really don't care about colors, right? If I have to look at a milestone or a speed limit milestone that's coming up, right? I don't really care about clarity, color, or whatever it is. So how do you optimize these sensors based on the applications? So that's another challenge, right? So we look into that as well. Now, if I have to look at the third critical anchor, right, which is HPC. So today, many people spoke about the importance of RISC-V and importance of AI throughout the sessions today. And AI workloads are going to drive a lot of the future HPC at the data centers. Now, in this context, what is very important is to look at memory specifically, right? If you look at memory, as far as AI workloads are concerned, there's going to be a lot of data movement as compared to a normal applications like if I look at a mobile phone also, right, between the processor and memory, the amount of data transfer between the CPU and the memory is going to increase significantly, and people are now talking about something called as memory wall and how do we overcome that, right? So here technologies like HBM, and more importantly, HBM combined with technologies like PIM, right, processor and memory, becomes more important so that we can optimize on bandwidth and we can optimize on power as well. And if I have to extend this a little bit more, if I have to go to the storage, right? As far as the storage is concerned, again, AI is all about not moving a huge amount of data to the storage, but it is about moving smaller chunks of data to the storage. And from that point of view, how do you optimize, right? That's where semantic SSDs or memory semantic SSDs become more important on the storage rather than normal SSDs. And if I have to extend this further, right, on the interface, how do I solve the bottleneck between the processor and the memory? So technologies like CXL also play a very big role. So the reason I'm laying all this foundation is also some of these core technologies, be it the sensor, be it the compute, be it the memory or storage, or with respect to even NPUs, right, from an AI point of view. These are some of the core technologies we work at our research center in India. Hopefully this sets the context, and going back to the template, many of the designs, I think I'm proud to say that it's not an organic growth, but it's a huge bet that the Samsung headquarters took on our R&D center to expand our portfolio in a very, very rapid pace.
Wonderful. Thank you, Balaji. Balaji and I will keep talking about memory because we have that in common. But Balaji, just one follow-up question for you before I jump to Neil.
Yeah.
Things like processing in memory, right? The research in this area is going on for decades. How does it actually manifest in a site, right? Because this is multi-decade kind of research sometimes, multi-site. So from an India standpoint, how does the India teams actually play? You don't have to give me anything confidential, but largely, does it come as a part of a broader global approach, or does it enable a specific design? Or
So definitely comes as part of the broader global approach for sure. But just to add, right, I mean, PIM's importance is going to be even important in a mobile context because people are talking about chat GPT or transformers even on a mobile phone, right? I think morning we spoke about image to text to image kind of things, how AI is going to redefine the media, right? Some of these things are going to be reality in your mobile phones. So PIM is extremely critical even in that context to enable high bandwidth and low power as well. So I would say that we are doing a lot of work looking at more application context, but we also co-work very closely with our headquarters. So it's a more a global context as well. Yeah.
Thank you, Balaji. Over to you, Neil. You are a little different from all of us, which is in a good way, because you're going to talk about how to incubate in the Indian startup ecosystem. So please do talk to that, and what kind of end markets are driving the design momentum that you currently have.
Thanks, Anand. So I'm going to start off with the templates, at least borrow keywords from what he said. So Encore has placed a bet on RISC-V. It's a lip service today, but we hope to make it a reality soon. And we are finding paths within the Indian ecosystem to get chips into the hands. Right? So we are playing both the things. At Encore, RISC-V, we believe is much more mature in the embedded space. It's where it can actually enter market. It can compete with existing parts, whether it's ARM, it's PowerPC, but those sort of embedded, low embedded IoT, narrowband IoT sort of segments. To give you more specific examples, smart cards, e-passports, you're looking at energy meters, these sort of things where India has a protected market. Right. This is where the government can induce policies, can have the ability to go Atmanirbhar without creating chaos in an existing system. Right. There's enough cake on the table, and we're talking volumes here, right? So we're talking about loading the fab, and obviously this is not 1,000, 10,000, or a million, but if you go through the recent tenders by the government to promote indigenization, there's a power meter which was of the order of 25 crore meters to be replaced over the next half decade. Right. And just add a layer of Atmanirbhar, just add a layer of indigenization, even if 10% of those chips have an Indian IP of sorts, right? Whether it's RISC-V or not, that's huge volumes that we're talking about today, right? So having said that, so Encore is more focused on those areas. We are working at the deep embedded, ultra low power, resource constraints segments, trying to replace existing solutions, right? So RISC-V has come up as a amazing alternative. It is not amazing technology. It's nothing new that you're going to find in RISC-V in this space. So the complexity is low. The demand from RISC-V on the fab is going to be very simple. You can have very low complex devices, slightly more analog heavy, definitely for sensors and IoTs that you're looking at. But the digital components are extremely simple. I think you can have multiple startups play in this field very quickly with low amount of risk pertaining to them. More importantly, I think the government has played a significant role in all of this with the C2S schemes that Encore has also been awarded one of those grants. The DLI schemes that I see a lot of startups availing to that benefit. The patient capital that this industry demands, and specifically the fabs or the startups that demand. I think the government has pinpointed, identified the pain points, and come up with schemes that enable them to take the step forward. Right. So the DLI, the PLI schemes, the 2.0 that was discussed a couple of weeks back in Bangalore. I think these are amazing initiatives by the government. It's reigniting the passion amongst the youth to take on digital design as a topic, as a career, as opposed to the generic AI, ML, cloud that we're suddenly starting to see. So I think the push from government, the investors coming into the right place, and our focus is majorly on volumes, where the complexity is low and there's enough pie on the table for us to grab on.
So Neil, thank you. But just one follow-up question. A year back, I'll be honest, I was a little cynical of another instruction set showing up. Many of us were. But the momentum in the last 12 months has been amazing. So the question I have for you is, if you have a target embedded application in mind between an ARM versus RISC-V approach, what's the real advantage? Is it go-to-market? Is it the flexibility of being able to tweak it? Is it all of the above? Or the government incent focus, help? I'm guessing it's a lot of many things, but little more commentary there,
Yeah,
please.
no, I think my answer is going to be all of the above because you've touched the right keywords, and I'm just going to elaborate a little on that. So, when you're looking at a transition from ARM to RISC-V, it's one, you are providing the lack of vendor lock-in to the customer, right? RISC-V is an open ISA. You don't have to go license it or find different vendors. There are going to be multiple players providing similar options across the world. So even if you've bought a chip and you want to change microarchitectures rather than the architectures, you will have solutions, you will have an evolution of your product, right? You're not dependent on a single customer. So that's the biggest thing. You're not dependent on someone else's evolution for your own evolution. RISC-V gives you that flexibility. Customization, definitely, you are no longer bound to picking a lot of luggage on the chip. You know, if you're an IoT sensor and you're looking at a Cortex M0, but you don't like certain parts or your firmware doesn't use certain parts of the instruction set, RISC-V gives you the ability to deviate. It gives you the audacity to go different than what the conventional is, right? And it gives you that audacity on the first day itself. That's the kind of leverage that RISC-V gives you. And from the government perspective, I'm sure a lot of people know about it. There is a Digital India RISC-V program, which sort of builds a huge stand on RISC-V being the instruction set of the country. But more importantly, trying to propagate it within institutions, trying to identify segments within the industries where RISC-V can propagate and make a stand for itself, right? So when you're looking to transition to RISC-V, I think all of these factors play a role. There's a confidence from the government, there's the customization angle, which makes it beneficial and gives you the uniqueness factor. And obviously, it's a good business model for you to evolve your product.
Got it. Wonderful. Thank you so much. I think we are probably 6 minutes away from lunch. As I promised, we'll probably not keep you away from lunch, but in the interest of time, if my panelists agree, we can open up for questions. I think the intent here was to give to all of you a sense of the kind of exciting, some high volume, some cutting edge, some disruptive designs that all of us are working on in our respective design centers. Many of them are poised for growth and scale over the next many years and help with the whole concept of fab loading globally and at someday in India, once we have that infrastructure up and running. So with that, I would like to open up for any questions from the audience, and then I see a hand over there. Yeah.
Hi, Neil. My name is Prasad Joshi. My question is to you, but even open to all other panelists. And it is a follow-on question to what Anand asked. You talked about a new design on RISC-V. What about existing designs or legacy designs? Do you see a trend or do you see any traction there that existing designs which are on the other competitive platforms are moving to RISC-V?
Absolutely. I think my focus, pardon me if I didn't get this right in the first shot, but RISC-V is going to find design wins as an alternative. So there are already existing solutions that people are either vendor locked or they're looking for a little more juice, a little less power, and you're trying to transition that to RISC-V. Or you just have a better business model in RISC-V. Either you found something that's open source and it fits your bill, and you're able to move to RISC-V more easily and stop paying royalties or have your own in-house design center on RISC-V. So legacy is definitely the momentum that RISC-V is banking on for now. Because as I said, in the embedded space, there's not much of wiggle room to innovate, but it's the solution and the business model that drives these products, right? So just to give you an example, we have done, I mean, in my previous avatar of working at Shakti at IIT Madras, we had actually worked with Indira Gandhi Center for Atomic Research, where they were transitioning from a 30-year-old ISA and a microarchitecture to RISC-V in a way that would not be RISC-V, but they wanted to be on an open ISA to start with, right? So there is definite momentum in the kind of track that you're choosing.
Just one additional comment. Good question. This morning when I think Bhakta talked about RISC-V getting into possibly a data center workload type applications, I felt more empowered because just sticking to IoT embedded would have made me a little nervous personally, personal comment. But the fact that you're beginning to navigate the entire spectrum of workloads and applications means you're becoming, in my mind, authentic as an instruction set, right? You're not just playing to a very point, because we know that IoT embedded, though very exciting, has his own challenges in terms of scale sometimes, because you will compete with ARM day in and day out, right? So that I felt that flexibility was amazing. Good to know. Wonderful. Good question.
Hi, good afternoon. This is Kishore Narang. I'm just a product and system designer. I think my question is for Neil. I love this, democratization of innovation, which we are talking about through RISC-V and all this kind of thing. But I'm a bit skeptical and maybe confused. Please help me get clarity. You're talking of the basic core being customized for different use cases, different like smart meter and all that, and I've been doing. But do you know what it takes to, what kind of maturity time from the core to customized cores, the silicon to a tape out and by products being done by the time this market that you talk about, smart meter, might be over? And then, are you looking at the startup ecosystem picking one customization at a time rather than what we today have, whether it is NXPs or STs or anyone? They have the core and then they have the customized version for smart metering, for maybe communication, for all those SoCs with different kind of add-on peripherals, whether for communication, RF and all that. Do you see this kind of a democratized startup ecosystem will be able to survive and continue and sustain and cater to the market?
So to answer your first question, where does the customization take too long? Are we spending too much time on things and are we losing the train at the right station? I don't think that's the issue. Encore has a solution for smart meters. It has a solution and for different sort of embedded systems. Not allowed to talk them on the public forum, but I'll be able to catch up with you differently. But the customization is an innovation part of Encore, right? So we've built on the tech stack so that you get the customization on day one within 24 hours. Now there's a customization of the core, there's a customization of the SoC, where you say that I want to use the same core for battery management, electric vehicles. I want to use the same core for narrowband IoT. I want to use it in my microwave. That's the SoC changing, but you're able to customize the core very fast for each of those SoCs, right? There are going to be players in the market who now start adopting RISC-V and building custom solutions or custom SoCs on a generic RISC-V core, right? We are trying to bridge that gap as well. So you don't have to go generic. You can go day one without a loss of payday as soon as possible to the market with RISC-V. So I believe that RISC-V enables, that was the legacy of RISC-V, that you can do all of these things on day one with amazing amount of flexibility. I think the only barrier that RISC-V is going to hit is the software stack, right? If everyone goes fragmented, if everyone starts deviating from RISC-V, how do they maintain software? But that's a longer discussion. That's an ecosystem discussion that RISC-V itself has to be involved. And they're definitely doing a lot of efforts in that space in order to move forward. Thank
Wonderful.
You. Thank you.
Any non-RISC-V question from the
audience? Yes,
audience?
please.
Yeah.
Hey, good morning all. This is Vasu from Phytech. So it's the question for the global semicons. I can see the major players from NXP, Renesas, Samsung. The only question what I want is basically, we have been doing a lot of research on the processor design, but coming from a manufacturing, yes, we would take a long time to set up the fabs in India. But why don't we spin out indigenous chip which can go along with your experience, the huge experience of say Renesas or NXP, Samsung. So why can't we could able to launch an indigenous microcontroller and produce this in volume? As we know already, there is a lot of market opportunity. So for me, it's very simple. UPI versus the global semicons. So how can I get a UPI kind of thing which generates for each chip a revenue for India? How long it takes? It's not a challenge because when you see the Chinese ecosystem, they hardly take 2 or 3 years to spin out. Today, as an embedded engineer, I know that I have been using a lot of Wi-Fi chips, a lot of camera chips based on different new SoC architecture. I am now not taking a name of RISC-V, but it's hardly a couple of years, right? So to the bigger players on Semicon.
So I think we got.
We should build microphone chips first.
Yeah, looks like. No, I think what you are touching a very nice point, and at this point is called deglobalization, and that's what we are talking about all these days, right? So this is the trend that we see, and that's why these questions are being asked. While so far the trend has been, okay, so the semiconductor industry working in multiple geographies will be fully efficient. Now we are asking why these chips are not in this specific country. So what we are doing is whenever, we are all making chips. We are making chips here in India, but for the whole world. Of course, in a certain umbrella, it can be NXP. And now Neil is starting, maybe his company is going so they are going to create a big company which is out of India. So this is going to happen. It's a general progression. So we started late of having indigenous development. But I think whatever my view is that we should continue to keep a global hat on our heads. We should build the technology, and that's the only way the technology can be efficient, technology can be cheaper. If we are all starting making chips for our own countries, right, they will not be very cost efficient. For sure, for certain things, I think it's possible, but if you are talking about a big scale, it is more efficient if you are working for a global scale. But that's my personal view. Maybe anything to add from your side, Naveen, or?
Yeah, just to add, I agree with you, Hitesh. But just to add to that, what we can do though, I mean, through all this global experience that we've learned, where there are indigenous startups, is take some of that knowledge learned and permeate it so that we build the ecosystem in India as well. Just wanted to add that.
No, I think point well taken, but I'll tell this, right? Silicon is at the bottom of the food chain, and the fintech UPI revolution happened at a very different part of the stack, right? You cannot underestimate the amount of effort it takes, and you would know, since you come from the domain. That's why when we're asking questions of RISC-V, the amount of software customization needed to go and build is so massive. So it's not probably worth it to start off with of course we'll have some local problems needing a local approach or a feature variation. But in terms of feature sets and instruction sets, got to think more global. And of course, we'll play a big role, all of us together. So, no, point taken. Good question, though. Okay, we are almost nearing lunch. Unless there is a compelling question that has to be asked, we'll probably close this session.
If no question,
no questions.
Just
thank you, everyone.
sorry.
Thank you. Thank you, panelists. You have one comment? Yeah.
I think the question was on the fab loading. Just to give this perspective, right? We talk about automotive. I think we have given a lot of examples about automotive, industrial, IoT. One of the points that I would like to emphasize, right? So there are various applications within automotive. We talked about autonomous cars. We talked about sensor processing. We talked about battery management. So we need plethora of technologies where we are building these technologies. So if we are talking about advanced processor, they are in 2 nanometer, 3 nanometer, 5 nanometer. When we are talking about microcontroller or sensors, so they are in 28 and 40. When we are talking about battery management, they are going to 90, 130 nanometer high voltage technology. So we need, as a semiconductor industry, wide variety of technologies, and which will continue. So I think from the semiconductor loading perspective, as we are growing in the ecosystem, if we are having indigenous fab, does not matter which technology. It can be 40, it can be 28, it can be 5. So we will have sufficient things to load those fabs here. At the same time, it will create a positive momentum. The startups like Neil is running, right? So they can go to indigenous fab, they can have it low-cost manufacturing done in here. So on one side, loading will not be an issue as per my understanding, but at the same time, it will create positive opportunities for the startups which are running out of India to have their fabrications done out of India and also very quickly grow their organizations, right? If they have design wins and if they have the market, so they can also grow up very fast. So I see this as an opportunity. Maybe any remarks from anybody?
Okay, thank you, fellow panelists. Thank you, audience. And if you have further questions, we can always answer it around lunch. Thank you, everyone.
A little bigger round of applause for keeping it crisp, short. Thank you, moderator sir, for doing that honors. Keeping it short. And thank you, please. Can you step forward for the group photograph? We open the floor for the lunch now. The dignitaries are most welcome at the first floor food court, and the rest of the guests, please join us in the exhibition hall 1, ground floor. Thank you, and see you sharp over here by 1:55 so that we can start our session. Thank